All right, welcome everyone to Redux Beyond React. My name is Aaron Powell. I work for Redify, and if you want to follow on to my random ramblings, you can follow me on Twitter, but that's only recommended at the point of a conference where I'm going to be sharing the content that I've done within a talk, and maybe not general purpose following of my ramblings. So today I'm going to be talking about Redux, obviously, but the scope of this is I want to talk about how we can use that without being tied to a specific web UI. So first off, though, I want to talk a bit about how do we get to this point of like why are we talking about a library like Redux, and why are we talking about it without React, and that kind of stuff. I also want to clear up a couple of misconceptions about Redux first up. Now, obviously, Redux and React, if you follow along in the JavaScript community, are fairly closely related. The reason for this is that Redux really did spin out of the React community. It was first demoed at the React EU conference in 2015. It was actually kind of a subset of a larger talk about time travel debugging. That was the context of the talk, and Redux was used as a way to represent how you can do time travel debugging. I'll talk a bit about that when we get into some live demos later. Now, it's got a lot of traction inside of the React community, Redux as a library and as a way of doing front-end web UI architecture. One of the main reasons that it grew in popularity was it was kind of pitched as an alternative to Flux, which was and kind of still is, the Facebook-backed way of doing data management inside of a React application. So that's kind of why it grew out and had that kind of strong connection to React, and why it's kind of perceived as you're doing Redux, you're doing it in a React application. And I want to break that perception today. But before we get into how we can use Redux in other UIs, I just want to talk a bit about how Redux works itself and get through to the kind of fundamentals of what Redux is. So there's three core pillars to a Redux architecture. We have actions. Actions flow through to reducers, and this is all tied then back to our store. So, an action, this is essentially something that happened inside of our application. We could think of it almost like an event. An action that is dispatched, which is the terminology used inside of Redux, of how you trigger a Redux action, or how you add one to what's happening, is you have to give it some kind of unique identifier. We need some way that we can address what type that action is, and as it's going through, so that it can be understood when it gets to our reducer. This function here on the right is a very basic action creator function. So the role of this function is that it's going to create a new action based off of some value that's provided in, and that action is then provided to the dispatch method of our store. So, the reducer. A reducer is listening to actions that are getting dispatched inside of our store. It's going to do something with them. It receives the current state of the application. So, what has happened to this point in time? What does the data look like inside of the React application that we're building this with? It gets the action that was dispatched against the store, takes these two together, and combines them to produce new application state. Now, the point here is that this is a pure function. So it's received everything that it needs to receive to make decisions on what it's going to do next. Now, it's receiving the action, and it's using the type of that action to determine whether it can do something. It's receiving current state to work out whether or not it can, to change what the current state looks like to produce new state, and that's what's returned. Because this is a pure function, it makes it very easy to create tests around. We can have our core logic of our application, or of our data lifecycle, is very easy to test. And this is a reducer function. We see it's got two arguments, state and action. We're doing some kind of check to see, can this reducer actually handle the action that's been provided to it? This one, in this case, it's looking, it can handle only a single type, which is the type echo. If it receives that, it's just going to create a new state, which is the value that got passed in. Think back from our action creator. The final piece is our store. this is really the most important part of our Redux architecture. It's where all data flows around. It's also the only place where state truly lives. It's the only one that's able to modify state. It's the only one that's able to say, this is the current state of the data that is inside of your application. It's also the one that's responsible for taking the action and then giving that across to the reducers. So if you've got multiple reducers inside of your application, it'll work out which ones that to pass that action across to, and then they can do their own logic in and of themselves. It's also responsible for handling middleware. So if we want to do something that can intercept an action before it's passed to a reducer, it can apply those middleware steps in a very similar way that the middleware works in like an ASP.NET Core pipeline or an Owen pipeline for ASP.NET full framework. And middleware is obviously a very common concept across quite a number of web server frameworks. The final thing that the store does is it notifies anyone that's interested that data has changed when data changes happen. Because it's the only one that actually owns data. It's the only one that has any kind of mutability to its data. It's the one that's responsible to say, hey, web UI, data has changed. You want to do something with that data, new data, or tell some kind of backend system that data has changed and you need to persist something or whatever it might be. So this is how we kind of connect all of this together. We create a store with a function that Redux gives us. I'm going to keep saying React instead of Redux because I use them so commonly together, and it's going to be really annoying for anyone that's like, but it's not related to React. So I apologize for that. So from Redux, we get a create store function. We pass it the reducer or the reducers that we're using within inside of our application. The second argument I'm passing to that is initial state. So initially, the state of the application is an empty string. I'm then subscribing to any changes to the data straight after that. And if something changes, I'm just doing console.log of the current state of the store. And then finally, dispatching an action against that using the action creator we created 2 slides back. So there are some interesting quirks about the way Redux works. As I said, actions need to have some kind of a type so that we can identify them. Now this is a JavaScript library, so we have a bit of a problem with that because, well, JavaScript is a very loosely typed language. It was until the introduction of classes, but they're not particularly prevalent, so we still treat it as a very loosely typed language where it's slightly less loosely typed these days. So inside of a JavaScript application, we would do a property of the object that's being passed in, and that property would be called type. And that's what we then use as the identifier of what type this action is. Now, as I said, reducers can't change the state that they're given. All they can do is produce new state based off of the information they receive, which is the current state and the action that was dispatched. So this can be a little bit of a challenge in JavaScript because everything is then passed by ref, not by value. So we can actually mutate the state object that's been passed in. But if we do that, well, we are in a situation where we can't guarantee that we have consistency as actions are dispatched. If a reducer has actually changed the previous object, well, others aren't going to know about that. So typically what we would do is we would use something like object assign in JavaScript to create a new object based off of the current state object, and then set any properties on that with the third argument. If you've seen object assign, basically it takes a bunch of arguments and smashes them left to right. So we build up and replace properties as we go along. The other thing, and if you're using a transpiler like all the cool kids are with Babel and Webpack and about 30 megs of node modules, you're probably using something like the spread operator, dot, dot, dot. So we dot, dot, dot on the current state and then set any additional properties, replace properties of the current state. The other option you can go with is something like the Immutable JS library, which is another one that has come out of Facebook, which creates a truly immutable object with inside of JavaScript that you can, anytime you try and change values, that actually creates an entire new object and stuff like that. But that introduces other complexities into the way the application works. A reducer can also not return undefined. Now, I'm going to assume that most people here are familiar enough with JavaScript to know that undefined can cause all sorts of problems with inside of our application. And really, do you ever want the data state of your application to be undefined? I mean, what's that representing about your application? You know, what's happened in your application where all the data about your application is, it's this, like, I have no idea what it means, but so essentially you can't return undefined from a reducer. Redux will actually stop you from doing that. Similarly, you can't return null. And everything that we send to a store, every action that we dispatch, has to be synchronous. Now in JavaScript, this can introduce another bunch of problems because we do a lot of asynchronous operations. Anytime we talk to a server, we're using fetch or we're using XHR. Those are asynchronous operations. Well, how do we deal with that if we have to make everything synchronous? Well, in the example of doing a server call, either that with fetch or with an XHR, we can decompose that as a couple of different actions. So we start an AJAX call, and then that AJAX call completes either successfully or unsuccessfully. So it's really two actions. And we can then do different things based off of whether we started an AJAX call, load a spinner, show a spinner, AJAX call is completed, remove the spinner. Now you might be thinking that you've heard this before. Now it's not a Unix system. It's an event store. And we're essentially talking about event sourcing here, guys. Well done, JavaScript community. You have invented something that we've already been doing. And you think you're cool because you gave it a funky new name and it's got the letter X in it, which means it's extreme and all that kind of stuff. But yeah, the JavaScript community loves to reinvent things that have already been invented. So bravo, JavaScript community, bravo. Okay, so the whole point of this talk is not to talk about React. So what happens if we want to use Redux without React? We want to go beyond React. Well, what if we wanted to use Redux in a non-web scenario? And jump over to a demo and realize that that's not a great resolution, but we might have to accept that and carry on. I might put the font size up a touch more. Okay. So this is almost as simple a way of using Redux as I could come up with about 20 minutes ago. Yeah, I'm not kidding, I wrote this earlier today. So what I have is an application that has no UI. At the very top, I'm grabbing the create store and apply middlewares functions off Redux. I'm making an action creator function that has a type of increment, and then we pass in a value that becomes a property called payload. We have a reducer that has state and action provided to it. Sets some initial state with count of 0. If the type is inc, then it will be able to use the spread operator. Use the spread operator to take the current state and then just replace the count property on it. Now, I don't have any other properties of that, but if I did have a more complex object, then it would only override the count property. I've also created some middleware here. This is just a logging middleware that intercepts the action as it's being dispatched. It will start a console group, put some information in that, and then in that group so we can do some inspection of every single action that's being done. We create the store, subscribe, and then just using a set timeout to recursively invoke this. So if we have a look at how that works, or how that looks in the console, let's make the console a little bit bigger. We'll run that. And I realized that I disconnected my network, so it's not actually going to have run, which is a problem. So just bear with me while we reconnect the network and talk amongst yourselves, people. This is not too big a problem. Normally, I keep my network off for conference talks because the last thing I want is a notification to pop in because someone is probably on Twitter and sending me messages or something like that, and not letting anyone in particular in the audience, like my colleagues. Okay. Cool, so we're back connected to the internet. All right, so there we go. Well, so we don't actually have a UI. Well, I mean, we technically do because we're logging out to the console. But this is Redux in a nutshell. It's actions are being dispatched, reducers are being invoked, subscribers are listening to that, middleware is being applied, and all of this is continuously going along in the background, and it's doing something, nothing particularly important with this example, but it's still doing something for us. So that's the crux of Redux and how it can be done without any sort of UI. Let's reload that so that it stops that running in the background. Okay, so let's jump back to our slides. All right, so as a non-web scenario of how we could use Redux, or I use web because I probably could have done that in Node if I wanted to, but whatever. So when we're looking at Redux without using React, now there's a lot of different web UI frameworks that people are using these days. Angular 1 or Angular 7, I think it is now. I don't know, the version numbers of Angular is too hard to keep up with. Backbone, Polymer, the other ones that are now kind of niche, where it's kind of really like Angular and React seem to be the ones that are sort of winning at the moment. There's Node modules that you can, or there's NPM packages that you can download that you can add to your application to essentially apply this with Angular. What it does is it replaces the way that you would use the controller as or the $scope injectable object. Instead you inject a Redux store, and that's what you subscribe to and you dispatch actions against instead. It can be also used with less popular web UI frameworks. And I'm going to jump back over to a demo of how we can combine this with a less popular web UI framework. So I'm going to be using Knockout. Apologies to anyone in the audience that is still using Knockout and that I'm just like ragging all over it. It was popular a while ago, in my opinion. But I wanted to show how easy it is to kind of shoehorn this into a basic application architecture. So you can see that it's not that different an idea or complex an idea. So here's our increment and all that kind of stuff. At the very top, on lines 21 and 22, that's my knockout code. So I've got a data binding. The text of the span is going to be the number of clicks that have happened. There's a click handle that I'm registering on the button that every time you click that, it's going to dispatch a new action. So the action reducer, that's all created there. Creating the store is down here on line 46. Now, I don't want my knockout view model to explicitly be tied to Redux. I don't want it to know that that exists. So the way that you would do this, and this is using some terminology that is very common when working with it with React, is that we have two functions, map state to props, or really this should be probably renamed state to observable. So that's state of the current store to observable properties of a view model, and dispatch to props. So this will wrap around the dispatch call against the store and then turn those into just normal functions that can be invoked from our view model. I just open up the view model and have a look at how that looks. There's kind of no signs that this is doing anything with Redux in here, really. The view model takes some properties when it's initially created. It has some observables on it. The register click function is just a function that can be invoked that uses the property props.click function that's passed in. So this is now something, it's a view model, it's very testable. It's not tied to a whole bunch of external dependencies, it's just tied to something that's being passed in. We can easily mock that out. And when looking at this from maybe an Angular perspective, you see a lot of that same sort of overlap. Now the final thing that I've got with inside of this script block is knockout apply bindings to set the view model onto the UI. This is just applying it to the body. I've created a connector function which will connect the store that I've got. Don't copy the code. So that connects the store that I've got. I created a few lines up using a couple of the map functions of state to props or state to observables and dispatch to observables or dispatch to props to a particular implementation of the view model, or a particular view model in this case. Now if we just open up that, have a look at how it works. So the connect function, like I said, receives the store, etc., etc. What it does is it gets the state of the application from the store, so when you initially do the bind, it passes that through state to props. It passes that through dispatch to props. It then sets up a subscribe on the store. And then finally, it creates an instance of the view model, passes through the mapping of state to props and dispatch to props. So that's how we get that kind of constructor argument passed to knockout. And then we subscribe to the store anytime the subscribe is fired. So every time an action completes and the reducer does its thing, we then get all the properties back out of the view model. We get all the state back out of the store. We then pass it through state to props and dispatch to props again. And then we find all the observables and set those back onto the view model with the new values that we've got by doing this subscribe call. So what happens there? So that's fairly condensed, and under the hood, this is what pretty much all of the bindings that you'll find for whatever web UI framework you're working with, they work this way. Essentially, just subscribing and taking away that, unpacking what's in current state of the store, and then somehow setting that on values that you've got with inside of the components that you're connected to. So if we come over to the browser, we have a look at how that works. Rocket science demos here where we click buttons and counters increment. I don't have any console logging middleware or anything like that, so you kind of just have to take my word that that's happening. But essentially, yeah, every time we click, then that's going through all of that subscribe method call and all that kind of stuff. So that's how simple it is to connect to any kind of web UI framework that you might be using. All right, and back to our slides. Okay, so Redux is pretty simple. There's only really a small number of concepts that you need to understand to know how Redux works. And I said, if you've been doing server-side development, you're probably familiar or have probably come across the idea of event stores and stuff like that. So it's not that different from that as a concept. Being able to introduce it to an application, again, is not that complex. You've probably been doing something similar in most applications anyway. The main difference that Redux brings in is the idea of data is only mutable in one location rather than multiple locations, which is particularly in Angular applications, that's kind of like every controller has its own scope that works with data. It's really more about how does everything talk to Redux? How does my knockout view model talk to Redux? Or how does set timeout, dispatch actions and stuff like that? That's the differences that you find between different frameworks. Again, it still comes back to the core idea of being able to call store.dispatch, but how you get that dispatch method, that changes it depending on how you're working with it. Also, the core of Redux itself is actually really quite simplistic. It's quite nice code and easy to go through. And when I first got into Redux, I really wanted to understand how it worked under the hood. So I decided to create a library called Redux. Pause for humor of the naming of this. Moves on because it's not getting the kind of humor that I was hoping for. I just want to talk about how it works internally then, so that we can get an idea of how this can be used in other scenarios. So I have a little application here that I can run. The Redux demo. There's minimal quacking involved in this, so don't worry. And when I was going through building this, well, what is the most complex application I can build from a command line that could be useful for people to understand? So I built a to-do list. No one's done that one before. Built a to-do list using Redux. Again, no one's done that before. So this is just an application. It's got a UI. It just happens to be a console UI. It's not a web UI. So I can interact with this and say, write a talk, or at least I probably should have done that one before right now. We're going to add another to-do of be awesome. And then a final to-do of heckle Richard. So I could go up and mark off a couple of these things as completed. I still haven't written my talk, so I'll leave that one as undone. I could change the visibility. Now, all of these are actions that I'm dispatching against my store. I'm dispatching an action to mark something as completed. That's just it flows through Redux as is pipeline. It goes to a reducer. The reducer goes, well, this object is now complete, so I'm going to set that and then update the state to be all of that. So it's too simple, really. But this is all done from a server-side application. It's definitely, it's not really browser client-side. So how does that then look internally? If I find the right Visual Studio Code instance, this is kind of the crux of what Redux is. It's 4 JavaScript files and an index.js. I think the actual implementation on GitHub combines these all into one file, or I think it's only 2 files maybe. But I broke these out because I was writing a blog series just to try and understand how it worked internally, because we were in the process of teaching a bunch of new developers developers new to front-end programming, React and Redux. We were teaching them how to go through it. So did all the building blocks of this is how you create the store, this is what it's doing internally, so on and so forth. So we have a function create store, which takes a couple of arguments. Internally in here, we have a subscribe function, which is basically just waiting until is adding things into an array that we're going to iterate through later. We have a dispatch function that does a bunch of our type checking. So make sure that you have a type property on your action, because we need to be able to identify it somehow. Throws an error otherwise. We then invoke the reducers with the current state of the application and the action that was dispatched. We go through the list of subscribers, invoke each of them, and then return. We have the ability to retrieve state and so on and so forth. In a nutshell, that is Redux. It is a total, like, taking middleware aside, Redux is 70 lines of code with some white space. It's not that difficult internally. And then the way that you would say combine this to a console application is I've just got a wrapper function to start with that uses either the actual implementation of Redux or my implementation of Redux. And it gets really confusing when I keep saying Redux and Redux, because they're 2 different things. And you notice the inflection and you can work out which one I'm talking about. We subscribe to our store, and then we update the command prompt based off of store change, the state change. Again, it's still writing to some kind of a UI. We're still doing some kind of UI change based off of what's happening. It just so happens that this UI is a console application UI. You can quite easily drop that into any kind of sort of server-side application that needs some kind of state. Okay, so observable stores. Another thing that a lot of people don't even realize, and I didn't realize this for a long time, is that Redux stores are observable objects. So what do I mean by observable objects when we're talking about Redux? Well, under the hood, they implement this primitive in JavaScript called system.observable, which basically allows you to create an observable stream. So you can create a stream of your store that you're going to listen to and perform operations against based off of what's happening inside of your store. Has anyone played with the RX framework? Cool. Cool. NGRX, excellent, cool. A number of people have played with RX, so you might be familiar with the concept of an observable from RX. There's JavaScript implementation, there's Java implementations, there's .NET implementations, there's bindings for different web UIs, Angular being one of them, stuff like that. But still, at their core, they're observables that implement this primitive type, system.observable. So what you can do from that is, one of the advantages that you can do with observables is you can combine multiples together to create a single observable stream of multiple different data sources. So if you're already using something like RX inside of your application to observe a particular set of data streams, you can also then create a Redux store, turn that into an observable object, and just add that as another data source to your RX stream. And other cool things that you can start doing with RX is you can do conditional subscriptions. So we haven't seen it in any of the demos so far, but let's say that I wanted to subscribe and only do updates based off of, like I wanted to update part of the UI based off of a particular branch of my application state. Well, every single time the subscription function is invoked, I'm going to have to, I need to do this, yes or no, based off of the, and if I've got a deep state object, I might need to walk a bunch of stuff. So it can essentially make our subscription function a little bit more complex or a little bit more tedious than I would actually need it to be. So conditional subscriptions inside of Rx means that I can observe the stream, but I can slice out parts of the stream and drop further down the chain based off of things that are happening and things that I'm not interested in. So essentially it maps the current store state to some kind of a stream that I can perform operations against. And as I said, you can combine streams together, and despite what Ghostbusters said, it's perfectly fine. Quiet crowd today. Is this thing on? All right, so another code demo or another demo. So I've created a application here. It's a clock. The clock face itself is written to by Rx. The time below that in the bit of text, which is a touch difficult to see, that is done based off of observing the store itself subscribe. So let's just start that. Okay, so we set the current time, and then you see that the tick's happening, 53, 55, 56 seconds, so on and so forth, and then the minute hand's moved. So that's all happening quite nicely. I'll come back to what's on the right panel in just a moment. I just want to go through some of the code here first. All right, so we've got a reducer. I've got a couple of different actions. One which is called setup, which determines whether or not I need to draw the clock face, just for reasons. If the action type is setup, I set a property of draw clock to true. If the type of the action that was dispatched is time, then I'm going to set draw clock to false because I don't need to keep drawing clock faces. I'm going to set what the previous time, the previous time observed was the current state's now value, and now is the action value that was passed in. And then I return new state based off of that stuff that's happened. I create the store down here. I subscribe to it. I get state. If there's a now value on the state, then I'm just going to write that out to the time tag using a moment just to get some pretty formatting. But then we start getting our observable stuff here on line 62. So rx.observable_from. So I'm giving it an object that I'm assuming is implementing system.observable. This will create me an observable stream. I can then start doing things like filter on the stream. So on line 64, I want to only draw the clock face if the state draw clock is set to true. So I can put a filter in that before I do the subscription to the stream. So that means that every second I'm firing off this action, but it's only going to draw the clock face once. So it will hit this filter function many times, but everything after that's kind of, it doesn't continue down the chain. Which gets a bit more obvious when we look at from like line 70 down, where I've got multiple filters. We're using a map to then, map is kind of like the map state to props function. So we're going over the state, pulling stuff out of it that we actually need, and then sending that across to a subscription function. In this case, we're going to update the clock when the previous minutes and the current minutes are not the same. So that's kind of how the clock face then ticks along. We finish off by dispatching a couple actions, which is the current time and so the initial setup, sorry, and then the current time. There's a bit of a bug in this application because the initial dispatch doesn't, the initial state doesn't have a previous time. We don't draw the initial clock face. That's why it sits at 12 o'clock because when we initially render out, it doesn't know to redraw the clock face because of the two filter functions that we've got on line 71 and 72. Then I just got a function that's bound to the button click that runs the clock and it will keep dispatching time every second. So now if we start that up again, times jump forward quite nicely, and we can go forward. Now, as I said, I've got this right panel here, so I'll talk about that in a moment, and that moment is now. I don't know why I did that, but okay. So I've plugged this into the Redux Chrome extension that allows me to essentially inject a piece of middleware that's watching what's happening inside of my store. You'll see that I have all these this time stuff down here, and what that represents is all the different actions that have been dispatched within inside of my application. I can see if I click on one of them, the action that was obviously a couple of seconds ago, at 32 minutes past the hour of the current day, and stuff like that. And I can see the type of that. I also have this timeline here at the bottom, which if I hit play, you'll see that the clock face has actually gone backwards. And we're stepping forwards now. We're replaying every single action as we're going along. You see that the seconds is ticking over. We've ticked over a minute. And this is all just happening because every action was synchronous. So I can replay every action in the order that they actually happened in my application. See why I say this is like event sourcing? It's obviously a fairly common concept to many people. Let's just fast forward onto immediate. I can also, say, dispatch a whole new action. Let's grab this one. And then we need to do a new date, 2017 of the 8th, 16. And let's make this 14, actually no. Yeah, we're 14, 20, 0, and 0. Now if I hit dispatch, we've just gone back in time. So we've wound the clock backwards because that's basically what Redux is doing, or our application is doing, is it's going, dispatch this action. It doesn't care that this is supposed to be a clock and it's supposed to be going forwards. So we can quite easily do that. I can also turn off points inside of this. So if I, come on, skip that one. So if I've removed that from the list. So now this is what the application looked at that previous point in time. Forward, backwards. This is what essentially what Dan was presenting at the React EU Conf was in the concept of time travel debugging. I can rewind and replay play forward my application, see what's happened. I can also do things from these tools like I can export all the actions, what the values of those actions were, what the state was at that point in time, to a JSON file. And let's say that I've got an application, it's in UAT, manual tester has gone through and found a bug, or it's in production and someone's found a bug. If we've got this running, or we've got this available, we can download the JSON, which represents every action that's been done. We can create a test, open up that JSON file, pull each step out, pull each action out, dispatch, 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 all the way through, and then assert on the end. We get an assert fail because we've got a bug in our application. I can fix it. My test now passes based off of how the user actually got to the point in time that they did it. That, to me, when I realized you could do that, was kind of like the mind-blowing point. It's like, this is so powerful. I can quite easily get a regression, check that in, write a test, check that in, and avoid having that regression problem come up again in the future because I'm able to reproduce everything that the user has done. I've been able to observe, and this isn't required for observables. This works with Redux just plain, so I could put that back into the console example that I did early on. I can connect this up to an Angular UI, a Backbone UI, a Knockout UI, a React UI, all that kind of stuff. It's very easy to plug in, and then we can just, this DevTools is just running, observing, and I can do all kinds of interesting stuff. So I can see, like, this is the state of the application. It's currently stopped. It's not trying to draw the clock. The previous time was that. The current time is that. Quite powerful, and this saves a lot of time from a developer's perspective. I like the fact that I can just get an actual repo, not, oh yeah, here's a couple of screenshots. Well, what did you do? Yeah, I'm gonna have to see if I can try that again. We've all been there. We've all been back and forth with a user or a tester or a colleague. It worked on my machine. Thanks. I'm sure it did. I trust you. Okay, so that was observables with Redux, and also how we can combine that with the Redux dev tools, and how we can use the Redux dev tools to sort of monitor what's happening with inside of our application, and get the power of the insight that can give us. So what about Redux without JavaScript? Now, one of the things I said that we need about an action, and this is like when I was doing my implementation of Redux, I started thinking about it was, well, because we have a loose type system, we have to rely on a property called type, and that's how we do it. What if I was doing it in a language that had a type system, like Fsharp? Because Fsharp. I wanted to essentially set myself a proper challenge and write this in Fsharp. So I had a crack at rewriting this in .NET, in Fsharp, because I was trying to think, like, all the stuff we've seen and all the demos that people talk about it's all in browser UIs. Well, could we use Redux on the server and not in the browser? Like, could we represent state? Because Redux requires, it's like user state essentially, or it's application state. Well, what if we wanted application state to be on the server? I'm just going to, like, full disclosure, this wasn't the first time someone had written Redux in .NET. There's like a C# implementation if that's more your cup of tea. But I thought I'd have a crack at writing it in Fsharp because I like to give myself a proper challenge. If you're not an Fsharp person, or like you haven't used Fsharp, don't concern yourself too much with the language or the syntax or stuff like that. This is more kind of illustrating pushing the boundaries of what you can do with this as a design pattern. So I create a couple of types that represent middleware, the middleware API and the store and stuff like that. I have a thing that completely broke my brain when trying to do a whole bunch of fallbacks and stuff like that. I then created this enormous type definition along here, which is basically the same generic argument being passed about 5 times in a row, and that hurt to try and write. Also, because I'm not particularly good at Fsharp. But here's our create store function. The full implementation is 53 lines of code for a type-safe implementation of Redux. I thought that was kind of cool. I thought that was, we had 70 lines in JavaScript. I've managed to shave almost 20 lines out of that. And a bunch of that is type definitions. Cool. So the way this works is it's a recursive function, because when you provide middleware, you either create the store with middleware or you create the store without middleware. When you're creating the store without middleware, you actually create when you create the store with middleware, you actually first create the store without middleware and then then recreate it with middleware over the top, and we replace the dispatch function with all the middleware chains. So in Fsharp, I have to create a recursive function to achieve this so that it works. In JavaScript, that's obviously a whole bunch simpler. I had to break only one kind of rule in Fsharp about nothing should be mutable because, well, somewhere data has to change. So we do have mutable data and a mutable collection of subscribers. I tried to do as much immutability inside of this as possible. And then I was like, okay, cool, I've written that. What am I doing with it now? Well, I'm trying to do something server-side. So I'm going to write a chat application. I've got a demo up here of a chat application written in Fsharp that uses Signaler as its chat protocol, essentially. Cool, so that's up and running. Let's open up a Chrome instance. Just close off these tabs that I don't need anymore. Localhost of 5,000. And my name is Aaron. Cool, let's just bump that up a touch. Then I'm going to create another tab. That one over there. And we'll connect another localhost instance, and we'll call this Richard. And then I'm going to create one in a different browser. Whoops. Where'd my browser go? There it is. Let's just resize that one. Really doesn't help when the browser wants to resize itself off screen. Come on, I want you small down here. All right, we'll come back to that browser in a moment, and we go, awesome talk, Aaron. Because that's what Rich is going to say after this. So this is sending back and forth because, well, these are just dumb clients and our state is on the server. So that's pretty neat. Thanks, Richard. Now, if I was to reload this browser and I'll just connect back as Aaron, because state exists on the server and not in the client, it just goes, well, here's the current state of the application when you connect, and I get back my chat history. Sweet. That's kind of neat. It also introduces some other interesting quirks. Let's connect another one, and because, well, names don't have to be unique, we'll connect another one called Aaron. Now, here I also have my history, because I've connected, and that's the current application state. The way that it works is that every key press sends an action back to the server, because if you close the tab, you come back, you want to be able to connect as the same user. You want to be able to pick up where you left off. But if you open two tabs as the same user, you go, isn't, and they both have values in them because it's just the one application state. We're now persisting everything server-side, and as I type into one, well, anyone that's also listening on the same unique user key, it will, it's all connected, and it's just the same application state. It goes, well, Aaron's typing stuff here, which means whoever is Aaron is also seeing all of that. Yeah, that's something that you've obviously got.
That's more like a normal conversation.
Yeah, that's true. That's more like a normal conversation that Richard and I would be having. And then they're just like, someone would just fall over. But kind of silliness aside, in terms of like we're doing a chat application that's got this weird internal state, like what would a .NET implementation be useful for? A Xamarin application. Building something on the phone, building a Win 10 application, HoloLens application, something that has like a single user context to it. Maybe you're building a really complex server job that runs. It's got some application state that needs to track over time. And you have one place where that data lives, flows down. Xamarin applications or mobile applications and desktop applications are kind of what I see as the core use case for this. Like I said, there's a better implementation or probably a proper implementation out there on NuGet. Mine lives in a GitHub repo because I wasn't going to inflict it entirely on the world. But, oops, wrong button. Internally, it works the same way as we would use anything else. So we have not that file. We have a SignalR hub that gets started when it gets started. Oh, wait, sorry. I got to open the correct file. If I remember where I put that, it's this one. Just click randomly in files until I find the code that I'm after. So we create a store. It actually has some middleware inside of it that when a new user connects, it will pump out and say, user has joined the conversation. So it does that. It actually dispatches a new action from the middleware. I don't think we saw that because I didn't have enough unique users joining. We set up some initial application state, which has got no users connected. There's no current message. Current message is being written. There's no users that are currently connected, but you could have it create, and it's automatically got a couple of different users because you've hydrated that information out of a database. We have a reducer that sits up here that just uses the power of a full type system and not JavaScript to do things like pattern matching. Depending on which action's been dispatched, we're going to invoke different things. We're going to do stuff with the state and whatnot. When you connect SignalR hub, all it's going to do is it gets the store and subscribes to that. So any changes in the store, we're just going to push that out to the currently connected clients. It exposes a dispatch method, which we actually call from the inside of the browser. So we call the SignalR dispatch method on the server. And I'm not going to go too deep into SignalR, but that's how that all works, and we dispatch a bunch of different actions against that. So that's how you could implement a server-side implementation or a .NET implementation of Redux in Fsharp as a console application. Cool. That sounds like a use case that I'm sure that everyone in the audience has. That's Redux in a nutshell. That's how you can use Redux without having to rely on React. We can add it to any web UI that we're looking at, or even non-web UIs, just anything that might have some kind of a UI associated with it. Or if we really want to stretch ourselves, we don't even need a UI, something that is just a stateful application. To me, like when I realized like all of that stuff comes together and that it was essentially just event sourcing, that was the mind-blown sort of moment. I'm Aaron Powell. That was Redux Beyond React. Thank you.